Derive and apply arc length. So here we're going to look at how we can derive and apply an arc length of a circle in radians. So let's draw a circle and let's mark in the center, and let's mark out 1 radian. So this is 1 radian, and we know the arc length of 1 radian is the radius of the circle. Now let's look at another arc, or another sector, and this time let's call it theta radians. And this arc length we don't know, let's call it L. But the ratio of the angle and the arc length is going to hold true in any circle. So we can say that the ratio of arcs is going to equal the ratio of angles in our circle, or in our sectors. So let's look at the first one. Let's take our bigger arc L and put it over our smaller arc R. And what was the angle of the big arc? Well, that was theta. We didn't know it. And the angle of our arc length of R was equal to 1. So we'll put it over 1. Let's multiply both sides by R. And theta over 1 is just theta. So we're just going to get L equals R theta to actually define our arc length. So it's a nice simple formula that any arc length is just going to equal the radius of the circle multiplied by the theta that encloses the sector of that arc. And it's very important that both of these angles were in radians. So this theta value that you have has to be in radians. So theta has to be in radians for this formula to work. So let's apply it to a question. So if we have 40 degrees and 8 centimeters, what's the arc length of that sector? Well, we know the formula equals L, so our arc length equals R theta. The theta has to be in radians, and we've got an angle in degrees, so we need to first convert that angle there. So to convert any angle from degrees to radians, we need to multiply by pi over 180. So we're going to have 40 times pi over 180. So we get 40 pi over 180. So the zeros will cancel out, and 4 over 18 is going to simplify to 2 pi over 9 radians. So 40 degrees is the same thing as 2 pi over 9 radians. And now we're ready to find the arc length. So L equals R times theta. So we're going to have 8 for the radius times theta, which we know in radians now. It's 2 pi over 9. So we get an arc length of 16 pi over 9 centimeters.